This is a slide that we looked at earlier in the lecture today. I've added some more detail to this slide now as we go into the final section of today's lecture. Remember, we said connective tissue is very diverse. There are many different types in the body, and we divide connective tissue into three broad types: connective tissue proper, supporting connective tissue, and fluid connective tissue. And we said that there are two kinds of connective tissue proper: loose and dense. Now, the extra detail that I've added in is that within the loose category, there are three types. And within the dense category, there are three types. So that means that if we go to the highest level of classification, there are actually 6 types of connective tissue proper. There are 2 types of supporting connective tissue, and there are 2 types of fluid connective tissue. Now, for the rest of the lecture, we're going to focus on the differences between the 3 kinds of loose connective tissue proper and the 3 kinds of dense connective tissue proper. Very generally speaking, loose connective tissue proper gets its name because it has fewer protein fibers and more ground substance. And of course, what I'm talking about here is the extracellular matrix. Extracellular matrix inside of a tissue contains protein fibers, ground substance, and water. Loose connective tissue proper has less of the protein fibers and more of the ground substance. Dense connective tissue proper is different. Dense connective tissue proper has more of the protein fibers and less of the ground substance. Let's take a look at the 3 varieties of loose connective tissue proper. This is the kind, again, that has fewer protein fibers and more ground substance. You're also going to notice that overall it has fewer cells in it. It just looks like a very loosely organized type of tissue. And again, there are 3 varieties. There are what's called areolar, there's adipose, and there's reticular. Now, one of the ways that we can distinguish these 3 types of loose connective tissue proper is by looking at their blood supply and looking at where we tend to find them. Remember, when we were talking about epithelial tissue, we said that epithelial tissue is avascular. Epithelial tissue doesn't have a blood supply directly to it. Connective tissue is different. Connective tissue can have blood supply to it. It just depends on the type of connective tissue you're talking about, because they vary in how vascular they are. Areolar loose connective tissue proper is the kind that has a very extensive blood supply. Now, you find this type of loose connective tissue proper particularly in the skin, in the deeper part of the skin called the dermis. So I'm sure you have managed to cut yourself in your lifetime, and you may or may not have experienced a very deep laceration before, but you know when you get a nice deep cut on your skin, it can bleed and bleed and bleed. You can blame that on the fact that your dermis is full of areolar loose connective tissue. Second on the list is adipose tissue. Adipose tissue also has an extensive blood supply. Now remember, adipose tissue is also more commonly referred to as fat tissue or just fat. Adipose contains adipocytes as the cell type, and those adipocytes are capable of storing fat. Now, I have some notes here about different kinds of fat. Fat is simply a type of lipid. Remember when we talked about macromolecules, we said there's protein, there's carbohydrate, there's lipid, and there's nucleic acid. When we look at lipids, there are three distinct types. There are phospholipids. Those are the ones that are found in your membranes. There are sterols, like cholesterol. And there's fat, or what is technically referred to as triglyceride. Now, fat is a molecule that is loaded with energy. In fact, it contains 9 kilocalories per gram. So the body uses it. The body uses it as a material for the long-term storage of energy. And if you've ever struggled with your weight, you know that fat or adipose can be a very stubborn tissue to get rid of. When you gain or lose weight, it's not that you're changing the cells inside the tissue, the adipose tissue. It's not that you're getting rid of them or adding more of them. What you are doing is changing the amount of fat within each cell. These adipocytes, these fat cells, can have the amount of fat or triglyceride altered within them. When you lose weight, those cells simply shrink down because they have less triglyceride in them. When you gain weight, those cells simply pump up or plump up with fat inside of them. So weight loss and weight gain is not about changing the number of adipocytes in adipose tissue, but simply by changing the amount of fat within each cell. The only way that you can reduce the number of adipocytes that you have is through liposuction, through physical removal of the cells from your body. Now, the other thing to be familiar with are these terms brown fat and white fat, and you may or may not have heard these terms before. They got their name based on their appearance underneath a microscope. Brown fat is simply the variety of fat that tends to be more abundant when we're very, very young. So newborn babies tend to have more of this brown type of fat in their adipocytes. This is a kind of fat that is particularly useful for keeping newborn babies warm. One of the biggest dangers to a newborn human or a newborn animal is loss of heat. They can quickly lose heat and they can quickly become dangerously hypothermic and even die. So it makes sense that they're going to store a larger amount of the type of fat that helps keep them warm. White fat is very different. White fat is the type of fat that you find in older human beings and other types of animals. This is the kind of fat that is used by the body as a long-term energy source. It also provides insulation and protection for the organs. It's dangerous to have too little fat, and it's also dangerous to have too much fat because these cells in this tissue, this adipose tissue, are metabolically active and secrete different substances depending upon how much fat they're storing. Now, the last kind of loose connective tissue proper is called reticular. Reticular is very different from both areolar and adipose in that reticular has a limited blood supply in it. Reticular loose connective tissue proper, it's quite a name, is found most abundantly in lymphatic organs. and it's providing the stroma or the supportive structure in those lymphatic organs. Let's take a look at these three types of loose connective tissue proper underneath the microscope. On this slide, we're looking at a sample of areolar loose connective tissue proper. It has a look, just in general, of disorganization, doesn't it? Remember, all loose connective tissue proper has fewer cells, fewer protein fibers, more ground substance in the extracellular matrix. So you can see cells. There are cells here and here. You can see protein fibers here. And then you can see protein fibers here in the green color. And of course, there's a lot of white space on this slide as well. Areolar loose connective tissue proper is found primarily in the dermis of the skin. And again, it has this very characteristic look to it. On this slide, we're looking at adipose tissue. It also has a very characteristic look. Remember, adipose is a type of loose connective tissue proper. It is a type of tissue that contains adipocytes or fat cells. And you can see, like all loose connective tissue, there are very few protein fibers in here. There are some. You can see this pink material here. But most of what you see on this slide is white. And all of this white is the fat inside of each one of these cells. So this is the boundary of a cell right here, and it is full of fat. This is the boundary of a cell right here, fat inside. All the way around you can see lots and lots of fat being stored. This is loose connective tissue proper of the reticular type. Now remember, unlike areolar and adipose, reticular loose connective tissue proper has minimal blood supply to it. We find it in lymphatic organs. You can see cells in here. You can see protein fibers, both this black type and also a pink-purple type in between the cells. And you can see lots of white space. These fibers, the black ones, happen to be the elastic variety, sort of wavy, branching, part of this reticular type of tissue. Now we're going to move on to the type of connective tissue proper that falls into the dense category. There are three types of dense connective tissue proper. There's regular, irregular, and elastic. Let's take a look at each one. Remember, dense connective tissue proper, in comparison to loose, has more cells and more protein fibers and less ground substance. So it's going to look a lot more ordered, a lot more organized. There's going to be a lot less space visible. Like the name suggests, regular dense connective tissue proper has all of its protein fibers very organized. They all lie parallel to each other. They're tightly packed together, and they're very good at resisting stress. Now, I don't mean the kind of stress that you and I experience. I mean the kind of stress that comes from pulling on a tissue type. Regular, dense connective tissue proper has a limited blood supply. And the place that we find it is in tendons and ligaments. Now, irregular, dense connective tissue proper, like the name suggests, doesn't have that nice parallel structure, that nice tightly packed structure. Instead, the protein fibers are going to be found in clumps and bundles. It's going to be much less organized. Now, that doesn't mean that it can't do the job that it needs to do. It does resist stress. And in a way, it does a better job of that than regular dense connective tissue proper. Irregular type, because it has its protein fibers oriented in different directions, can resist stress in all directions. So this type of tissue can resist pulling and pushing and twisting and so on, whereas regular type can only resist it in one direction. Now, unlike the regular type, the irregular type has an extensive blood supply. Now, where do you find this? Well, it's present in the skin, down in the dermis. It's present in the coverings around muscles, which are known as sheaths. It's present in nerves. It's present in the bones. It's also present in capsules or fibrous coverings that surround our organs. The last kind of dense connective tissue proper is called elastic. Like the name suggests, this type of tissue has a nice stretch and recoil ability. It too, like the regular type, has a limited blood supply. Now, where do you find it? It's present in the walls of the arteries. It's present in the vocal cords. It's present in the trachea. And it gives all three of those structures the ability to stretch when the need arises. Let's take a look at these different types of dense connective tissue proper under the microscope. On this slide, you're looking at dense regular connective tissue proper. Remember, like all dense types of connective tissue proper, it has a very regular look to it. All of those protein fibers are oriented parallel to each other, and they're all tightly packed together. This is a very characteristic look for dense, regular connective tissue proper. Now compare that to the irregular type. In this case, rather than seeing all the fibers oriented in the same direction, we have all the fibers oriented in different directions, and they're all bundled up. So there's a bundle right here, there's another bundle right here, there's a bundle right here. It's hard to look at this slide and see this. You have to use your imagination a little bit. But remember that this is a two-dimensional view of a three-dimensional tissue. So this bundle of fibers might have the fibers actually pointing directly towards us, coming out of the screen towards our faces. Whereas this bundle that looks so long might have the fibers oriented flat against the screen. These fibers, in other words, are pointing in all different directions in three-dimensional space. Lastly, we have the elastic type of dense connective tissue proper. I think of elastic dense tissue in comparison to regular dense tissue. If you look at this kind, the big difference is these elastic fibers. This is what I mean when I say that they're commonly stained black, and they have a very characteristic wavy pattern to them. All of these abundant elastic fibers are going to give this tissue a lot of stretch. that brings us to the end of this lecture about epithelial tissue and connective tissue.